Hello everyone. Today I am going to discuss about thermoelectric power generation and thermoelectric devices. So what do you mean by the term thermoelectric? The thermoelectric, this word is a combination of two words, thermo and electric. And as its name indicates, thermal means heat energy and electric means electrical energy. So thermoelectric power generators are the devices which is used to convert temperature difference between two junctions into electrical energy. So in my previous video lecture, I have discussed about thermocouple and Seebeck effect. So the working of a thermoelectric generator is based on Seebeck effect. According to Seebeck effect, a loop of two dissimilar metal develops an EMF when the two junctions are kept at different temperature. That's why this is also referred as Seebeck power generation. Now this is the basic block diagram of a thermoelectric generator. This is the thermoelectric device. So thermoelectric device is basically a thermocouple. And in a thermocouple, one junction is heated. So this heat source is used to heat one junction. And another junction is kept at comparatively lower temperature. So heat sink is used for that cooler junction. Now there is some heat transfer interface between that thermocouple or thermoelectric device and the heat source. This is the heat transfer interface. And also there is another heat transfer interface between that thermoelectric device and the heat sink. Okay. Now when there is a temperature difference between the two junctions of a thermocouple, a voltage is developed across the two junctions. That voltage is denoted here by V. Okay, now if we connect an external resistance RL, then a current I will flow like this across this loop. Okay, so this is the thermoelectric generator. Now the power generated due to this Seebeck power generation is single phase DC, and the power is given by, if P is the power generated, it will be equal to I square RL, where I is the current flowing across the loop and RL is the external resistance connected. Okay. Now the output voltage and the output power, they can be increased either by increasing the temperature difference between the hot and cold ends, or by connecting several thermoelectric power generators in series. Like this is one thermoelectric generator. We can connect many thermoelectric generators in series. Then it can cause the temperature difference across the two junctions to increase. And if the temperature difference increases, the generated voltage and generated power is also increased. Okay. Now the current produced by this thermoelectric power generation is DC in nature. Now if we want to convert this power into AC, then we have to connect inverters. And if we want to step up the voltage level, then we have to connect a transformer. And the one of the important thing about this thermoelectric generator is that the energy conversion through this thermoelectric generation is reversible process, that the direction of energy flow can be reversed. Like if we remove this external resistance RL, okay, and we can if we remove any externally connected voltage source, then what will happen? Then we can draw power from this heat source, and if when we have drawn a certain amount of heat from the heat source, its temperature will become very low, and at a certain point it can work as a refrigerator also. This is the most important thing about a thermoelectric power generator. Okay. And this is the difference between a thermoelectric power generator and a normal power generator. Now coming to the expression for the voltage and power generated. As we know that the generated voltage V, that is proportional to the temperature difference between the two junctions. So if the temperature difference between the two junctions is denoted by delta T, then we can write V is proportional to delta T. Now we are putting a constant term alpha. So we can write V equal to alpha into delta T. This alpha is known as Seebeck coefficient. Okay, this alpha is Seebeck coefficient. And if R be the internal resistance of the thermoelectric power generator, it is the internal resistance, then what will be the total resistance of this thermoelectric generator? It will be R plus RL. R is the internal resistance, RL is the externally connected resistance. So it will be the total resistance of this thermoelectric generator. So we can write current flowing across this loop will be equal to the voltage generated across junctions divided by the total resistance. So I will be equal to V divided by R plus RL. And if we replace V by alpha into delta T, so we can write an alpha into delta T divided by R plus RL. Now we know that P is equal to I square RL. So if we substitute the value of I here, we can write alpha delta T by R plus RL whole square into RL. So this will be the expression of the power generated by a thermoelectric generator. Now the power will be maximum when R is equal to RL. Then power generated will be maximum. Now if we substitute the value of R equal to RL, we will get P max equal to alpha delta T whole square divided by 4R. So this is the maximum power generated by this thermoelectric generator. Thank you.